All right, so here's the theorem. If f is differentiable at some point x equals a, then the equation of the tangent line L of x, which stands for the linearization of x, is f of a plus f prime of a times x minus a. That looks like something brand new, doesn't it? Does that look like something brand new? It's really not. Let me rewrite that for you. L of x minus f of a equals f prime of a times x minus a. Well, that should be an a there. What's that look like? Well, L of x is the same as f of x, which is just y. If you plug an x value into y, sorry, if you plug an x value in, you get a y value back, don't you? F prime means what? Slope. Then we have x minus another x value. This is y minus y1 equals m times x minus x1. It's point slope form. That's all it is. So don't be intimidated by it. It's just point slope form with different lettering. That's all it is. So the L of x, that means linearization. F of a is what you get when you plug a value in. F prime of a is the slope at that value. Let's see here. This is kind of a big deal. This point x equals a is the center of the approximation. All right, so find the linearization of 1 plus x to the 1/2 power at x equals 0. So this is the center. We're centering the approximation around x equals 0. And it means that the a value we're going to use is 0. We're going to use a value of 0 for a. And let's write it out here. We're going to use this approximation at 0 to approximate 1.02 to the 1/2 power, and then we're going to determine the accuracy of the approximation. All right, so there's some stuff we need. If you look at this formula, we need to know f of a. In this case, we need to know f of 0, right? Because a is what? 0. I need to know f of 0. I'm going to have to figure it out. F of 0 would be 1 plus 0 to the 1/2 power, which is 1 to the 1/2 power. Now, what root is that asking you to take of 1? It's the square root of 1, which is 1. I'm also going to have to know f prime of a. So I have to know f prime of a, which means I got to take a derivative. Here's the function, 1 plus x to the 1/2 power. Where's the half go? Out front. And then you'd have 1 plus x to the negative 1/2 because you decrease the exponent. And if you follow the chain rule, you're going to take the derivative of 1 plus x. What is the derivative of 1 plus x? 1. So we're not going to write anything else down. And I'll rewrite that. That's 1 over 2 square roots of 1 plus x. All right, so now it's time to plug that 0 in. F prime of 0 will be 1 over 2 roots of 1 plus 0. Which happens to be 1 over 2 when everything's said and done. 1/2. So we have found f of a, we found f prime of a, we know what a is. The question is, what is x? Because notice that's in this linearization equation. It's sadly not x equals 0. That's where you center it. That's your a value. That's kind of a line of confusion right there. X is the distance from the center. Now we're going to approximate 1.02. So the distance is 0.02. So x is 0.02. Move up to your equation. That's what x is. It's the distance from the center. We're just going to plug everything into that linearization formula. We're actually doing the linearization of 0.02 because that's the distance. And it is f of a, which we found to be, sorry, f of 0, which we found to be 1, plus the slope, 1/2. And in here we would say 0.02 minus 0. We're just following a formula. We do x minus a. And we would get 1 plus 0.01, which is 1.01. Again, I know this doesn't mean much to you, but if you were alive in the 50s and 60s and didn't have access to technology, it meant a whole lot to you. This is the math they used to make the earlier nuclear warheads. Like speaking English? They used approximations. None of what you have is possible without that. Do you at least understand that? None of it's possible without that. Again, it died in the 60s and 70s with the rise of computers, but it's still there. You wouldn't have anything without the past. We are supposed to determine the accuracy. How accurate is it? Well, it would be, accuracy is going to be how far apart you are from the actual value. The accuracy is the absolute value of whatever the square root of 1.02 is minus your approximation. And we can figure that out now. We can, and back then people could too. I didn't include the absolute value bars. Calculator reports that as negative 4.95 times 10 to the negative fifth. As absolute value, so 4.95 times 10 to the negative fifth power. You can kind of see how close they are. Square root of 1.02, 1.009. Really not that far off, are we? Are we? No. That's the difference between the two numbers. 4.95 times 10 to the negative fifth power. Very, very tiny difference. When you report this, like if you're asked to report the accuracy, you decrease the exponent by 1. So we are actually accurate to 10 to the fourth power. Sorry, negative fourth power. So just decrease it by 1. Yeah, by increase in this case. Increase. I'm going to do another example of this particular problem. We're going to approximate the square root of 1.5 using the same methodology. Okay? We're still centered at x equals 0. Now, we've got everything in place. Remember, this is our a value. A is 0. The x value is the difference. X value is the absolute value of 1 minus 1.5, which in this case is 0.5. We're going to find the linearization of 0.05. We're still going to have pretty much the same setup. F of 0 is still 1. F prime of 0 is still 1/2. In the parentheses, we have 0.5 minus 0. So linearization of I don't know why I said 0.05, of 0.5 is going to be about 1.25. I know this is exciting stuff. It's still not actually horribly bad. The actual value is about 1.22. So it's actually still fairly accurate, but not all that accurate. Now the error, or the accuracy, is that thing minus 1.25, the absolute value taken. That is 10 to the 2.5 times 10 to the negative second power. So it's accurate to 10 to the negative first. The whole point I was trying to get at here is as you move away from the center, what happens to your accuracy? Do you go up or down? It goes down. Makes sense. You're moving farther away from the center. And we'll continue that tomorrow. And if you didn't finish your quiz, you got direct studies, I guess.
I have one more question. Can I do it real quick?
Yeah. Enjoy your day, kids.